Alright, this is part 2 for the 2020 GMC Sierra low speed CAN bus issue. So I'm in the GM service data. We're going to go to service manual. I do want to talk about a couple things from the previous video. First off, we go to power and signal distribution, data communications, schematic and routing diagrams, data communication schematics. We're going to go to the first we're going to go to the data link connector, and if you look here on the DLC, make this bigger. Remember, we got 120 ohms across each bus, 311, 614, 1213. Well, in this newer truck, you're going to have 120 ohms because they're running two 60 ohm resistors in series, not two 120s in parallel. So 60 and 60, you're going to get 120. When we did that yesterday in the truck, that's what we got. So that tells us our term resistors are good at the DLC. Because, you know, here's all your DLC pinouts, your serial data gateway. So the DLC pinout goes to the serial data gateway. That is the term resistor, so that is correct. So now we're going to go, here's all your CAN bus, your low speed CAN, your high speed CAN, all your stuff. We're going to go to the low speed CAN because that's the issues that this truck is having. And if you pull it up, you look in here, on the low speed CAN right here, your steering lock module, which you had issues with, HVAC module issues. Your BCM is part of it. Remember, it does go into other modules. HVAC controls, front camera, keyless entry, parking assist, seat memory, accessory power, inflatable with your airbag, rear game, all these other modules, your side, left and right side, object modules. So this is the bus that we need to look at. And if you look, you go through a J227 joint connector, J202, and a J479. On the other end, you got your serial data gateway module and your trailer lighting control module if it has the RPO code of U1 Delta. We'll look at all these RPO codes next. But we want to get to these joint connectors to isolate the network and get behind the serial gateway module and scope it. Another thing, let me pull up here. So I just wanted to go over some of these service bulletins. So this service bulletin is intermittent service column lock message, which we had, but this is basically telling you to do a software update with SPS2, which we can do, but we're not going to do that right now. We have other issues. I'm going to show you one other service bulletin. So the other service bulletin is this one here. SPS programming issues, no comm, IPC erratic, various IPC warning mills, which he has. Certain cruise speeds when on set, communication DTCs, which he has for all these. But basically what they're saying here is if there's an aftermarket lift or tire size calibrator in series with the BCM X1 connector like this, that will cause issues. I looked under there. I'll look again, but I didn't see nothing. I was hoping that would be done. But it tells you in here, the cause of these concerns could be an aftermarket device plugged in line with the BCM X1 connector shown below. These aftermarkets are typically controlled to change the speed calibration with different tire size installed. These devices are not supported or recommended by GM, and the conditions created these aftermarket devices will not be covered under warranty. So that could be, we're going to look again. I didn't see it in there. So if we don't see this, we're going to go down with the scope way. If we see it, then we're done. Another thing I looked at is I called GM Tech Line Service Connect, or Tech Line Connect guys. This, you can't get a VCI or CSV file to program. You have to use this to plug it in. GM doesn't offer a software for these aftermarket boards. So I'm going to look at the bottom to make sure the BCM connector, there's nothing in series on the X1, and then we'll go on from there. Alright, so if you look under here, that's the BCM right there. I looked all around. There's no inline connector for the tire calibration. So we got to go to, I want to go to the serial gateway module, which is, it's either this module or the one above it, according to service data. If you look here, my plan of attack, well, serial gateway module, remove that bolt, you get that, Steve, you should get a new computer. So I'm going to put my fist through this one. But you remove that air duct, And then there's the security gateway module. Looks like there's oh gosh, 2 or 3 connectors. We got to find out which one it is. Looks like 2 connectors right there, which we'll look at service data for that. But if you go back, the reason I'm trying to get to that is schematic and routing diagrams, datacom, low speed bus. So I want to get right here to X1 pin 20 serial data gateway module. They call it K56. I want to get to that and scope on that side. So we'll do that next. All right, so what we're going to do now, I scanned it all. We're going to clear all these codes because it's not doing it right now. These are all history codes. But in the meantime, I want to get to pin 20, which is right there, which is going to be circuit 5060, 5060, low speed GM serial data. And if you go back, again, what I'm looking at is going here, data, schematic, data, low speed LAN. We're at pin 1, or connector 1, X1, pin 20 on the serial gateway module, the K56. We're scoping right there. And if you look, see, what'd you do with the flashlight? It's in my pocket. That's what he did with it, right, Steve? Yeah. So that's the serial gateway module. We're on the right pin there, the green wire, and I'm scoped in there. Key on engine off. And what I'm looking at here, I'm going to rerun diagnostics, fault scan. But let's split screen this because I got my scope set up so we can see this at the same time. And there's our signal right there. Buddy, look, it's already coming in green, so we don't have an issue with our signal. That's 0 to, gee, I don't know, 4 7/8, 5 volts. So you can make it smaller here, the time frame faster. But I'm going to go back to 5 milliseconds. Seen a high spot there. And what's that all about? I don't know. We're rescanning it as we're scoping it. I have key on engine off. We're scoped there. Key on engine off. We have no messages right now besides, you know, the hood's open and stuff, because I'm using a chassis ground up here. So let's look at a report here. So it's not acting up, so I don't really see any anomalies there, obviously. It's a 1-wire signal. Because if you look, there's 1 wire that goes to all of them. Now we'll go back and talk about the DLC. That's different. And the term resistor we mentioned a little bit ago. I need to talk on that again. Park and assist module lost comm. It's history. Some BCM lost comm. Trailer module. Let's clear these again and see what we get. So they're all green except this park assist module. But our bus looks good. Lost comm with trailer interface module. It could be a separate issue, but we'll fault scan it again here. I want to see this thing throw a ton of codes. See that jump up there? I want to see him throw a ton of codes, and I also want to see it. Now I don't know if it's jumping up because we're talking to it or there's an issue, but I want to see these go red or orange or whatever the heck that color is, or no response, so you can see on the scope side with the, you know, mirror image here, not mirror image, the split screen, see what our issue is. I want to see I would imagine the bus would change. So I've been scanning this thing a few times and it's still green. The scope looks good. Now you see some high spots in there once in a while. That's only when I'm talking to it with the scan tool. But again, we're scoped right there. So what I did want to talk about, why that's finishing up there, is what I wanted to show you guys. So we're in the low speed, but if you look in here, this is a high speed gateway expansion. There's a term resistor 120 and a term resistor 120. You run them in parallel like they are, you're going to get 60. So there is 60. But when you go to the DLC or the serial gateway, you're getting 120. It's kind of like a Chrysler in a way where you got to get past that to actually read this, the data, past that module, and that's why we're past it, or past the DLC. So there is term resistors in there, right? And that's a 2-wire can high, can low. But what we're looking at is a 1-wire 0 to almost 5 volts square wave, right? And it's good there. We don't care about that. One code in that is for TACM and the BCM. It's for the, let me see what it is again. The lost communication with the trailer control module. We don't care about that right now. But watch this. Nothing's jumping up. When I hit fault scan, it'll jump up once in a while. Just because I guess it's pinging the modules. Right there, did it, and it's scanning. Did it again right there. So yeah. So another thing I want to show you. So we talked about the term resistors. I want to go back to description and operation. This is a lot of information here. How the data link communication works. BCM is the gateway module. The power mode master. The serial data gateway. The low-speed microprocessor, the high-speed microprocessor, the high-speed GMLAN bus, DLC bus, chassis bus, blah, 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 all these buses. Gateway expansion, Ethernet, if equipped, most if equipped, FlexRay if equipped, low-speed bus, circuit 5060. Now, if you remember, that is the circuit we're on, it's 5060. I wrote it down there, 5060. This is a application for high-speed data rate is not required, which is less complex system. It talks about the baud rate and all that stuff. So this is a single wire low speed network, does not use terminating resistors at either end of the network. The data symbols can be transferred over the bus or represented by different voltage signals on the bus. When the low speed GMLS bus is at rest and is not being driven, there is a low signal voltage of approximately 0.2 volts, which represents logic 1, where the logic 0 is being transmitted, the signal voltage driven high to around 4 volts or higher, or again 4.8. So that matches that. Again, what I want to see, now we could go over all this stuff for all the other buses, but I'm concentrating on the low speed CAN bus. Not the low speed, not the low speed DLC bus, but the low speed CAN bus. The low speed DLC bus is a different terminal, and you know, talks about terminal 11, 13, or whatever it is, 3 and 11. Let me see here. Hopefully my phone doesn't die. I gotta charge it again. The low-speed microprocessors programmed moved by the X84 data link connector terminal 1. The low-speed microprocessor of gathering signals between the object high speed is terminals 3 and 11. So that's all that stuff there. So that's probably maybe why we didn't have in part 1 of this series. I didn't have any data as far as pins 3 and 11 when we're scoping it for a low-speed bus. So we can go through that more. I need to charge my phone before I film more, and we need to get this to act up so we have codes and or no comm, preferably no comm, to see what our bus message looks like and go from there. Alrighty, so I wanted to show you some other stuff quick. Terminal 1 is actually the low-speed GMLAN serial terminal low-speed DLC bus. Yesterday, or in part 1 of the video, I said it was 3 and 11. I mean, it is, but it goes through the gateway module. So if you look in here, or not gateway, the serial data module, if you look in here, K56 serial gateway module, the data bus diagnostic tool will not work with vehicles equipped with this module because it's got to get past that, and that's why we're scoping past it. Also, the low speed bus, which is circuit 5060, where the hell did it go? Right there. Continuity checks cannot be made between the X84 data link connector and the control module on the low speed bus. But it says in here somewhere it is pin 1. I showed you earlier, but it said somewhere else in here. And that's what we're doing. We're doing a single channel right now. We're on pin 1. That's what we're doing wrong in the first video. So we got a message here. And it looks good because we don't have issues right now. All right, it shows it here. Low-speed microprocessor. The low-speed microprocessor is programmable via the x84 data link connector terminal 1. So that's where we're at there. Terminal 1. You can see it on the scope right there. Let's get back to the split screen, and we need this thing to duplicate. All right, so we got over messages coming up around the interstate. Sorry about the glare, but it's acting up finally. And if you look, the scope catches up here. Let me reset my scope. All right, so if you look here, we lost comm there, but look right there, it's acting up right there between all that. There's a bunch of like corrupt messages almost looking in there. You gotta look at that. So let me scan this again. This glare is bad, but we'll try to get it here. Yeah, look at the messages on the right when it's scanning or when it's scoping. There's a bunch of dead space between it. And look, it just went solid, open. There's too much noise on the bus. Look at all that. I'm gonna hit fault scan again. So we're fault scanning again. Look, it just dropped way down. The bus dropped way down. Then it went up, the way down, up, way down the 2 volts up. Then it got solid. Bunch of hash, way down up. But we have no comm to the low speed bus right there on those modules. Again, sorry about the glare. Look at that, way down, up. It's all messed up. All messed up there. %. So there is going to be those high spots once in a while like that right there, because when we're scanning right there. But let's get this thing to finish scanning. 97%, 100%. So no, yeah, look at that now. So no, where my thumb is, left thumb, those modules aren't online. Way down. Bunch of way down. It's the bus is all messed up. So let me do something next. All right, I got rid of that, so now we got rid of the split screen. Now we're just done. Still showing the messages right there. Man, that glare's bad. Let's look at these a little bit closer. Yeah, look at that message. That's not right at all. Look at all that. Your square wave, and then it's like going to, I'm trying to get that on film there. Weird, very weird looking. Let's go back and get our scaling set up. Come on, computer. Let's go back to a 10 volt. Put a trigger on. Is it good now? Seems better now. No messages on the cluster right now. Want to do it again on when we're doing the scope here. Alrighty, it's doing it again. Service restraint system. The bus looks like there's way too much noise on it. There, now it's good again because the air's blown cold again. And look how it cleaned up on the scope. Now it's doing some weird step. Now, yeah, I just heard it do it. I saw it there, and now the bus looks corrupt again. For sure. So we're driving down 84 here, doing it again. And then the bus looks corrupt. See all that hash in there? All that noise? It's like there's no spaces between it. It's like a module's talking over another module or something. And then when it goes away, it goes back to normal. But there's gonna be a ton of U codes in there when if we can talk to it again. Yeah, right there, it's doing it again. Let me zoom in on here. Look at those bus messages. Like this does not look right at all. Like that's not right in the square wave. Either is that, and I think that's thrown either is that, or that, or that. Doing it again, it just looks like crap. So if you look on this, when I pause this here, this is bad. Just throwing the messages. If I zoom in, I need to get my screen recorder going on this thing. Yeah, look at that. That's all the bad messages. And then there's your square wave there. Let me get this set up again. Alright, so we're split screening it again. Remember, don't worry about those high spots right there when it's scanning. But it's scanning right now, and look, no comm to these modules. And air's warm. I don't know if you can feel that in the video, but it's pretty warm. But it's doing all those messages again. And look, it looks like there's a ton of noise in there almost. Right there, it looks at, I want it to come back. Let's finish scanning. We're at 85, 88%, 91%. That no high spot is from scanning. Okay, we're 100%. All these issues, and it's warm air. And look at that. That is all of our issues right there on that scope. So when it comes back, it must be coming back again. Maybe not. It's fault scan. Fault scan again. Yeah, I guess it's not. It's still warm air. Air's getting warm because the HVAC module is controlled by that bus. See, it picked up that module there, so there's a code in there. But look at that. You go in here. So when you zoom in and out, yeah, that's the corruption that is right there. So if you look in here, there's your square wave, but you go over here, these are, look at that. That is causing issues right there. That is what the problem is. Now we got to figure out what's causing that, if it's a modular connection. Get this set up again. So we got to talk to one module there. It's at 100%. Fault scan again. We set our scope settings. Good. Next time I'll use a screen recorder on this. It'll be a lot easier to see. Doing it again. Scanning, no comm again. All the same messages, service everything. Still driving on the highway. That's probably like 100 degrees out here. 104. It's ridiculous. So now I want it to, we know we got some bad data here. I want it to get back to normal and move on. So what we're gonna have to do is I want to see it, well, we saw it when it was normal because we had it earlier in the video. It'd be nice to see it normal again. But what we need to do now is get those joint connectors. We need to keep doing it when we go back to the shop and go to those joint connectors and pull one at a time and see if it's a module causing this issue or a connection issue and go from there. Right, so right there it's bad.
Sounds good.
Bad right there. You can see all that crap in there. And just before I turn the camera on again, it was doing good back and forth. Bad, good, good, bad. Good right there. Well, there's a lot of hash, but, or not hash, but a lot of module talking. We're gonna go ahead and recycle power. Can you go ahead and shut it off? And there's our bat again. So open the door, close it. All right, go ahead and start it again. So that's bad there.
It's not starting.
Oh, it's not starting now. That started. There he goes. Shoo. So it's still bad there. But when it's good, it looks like a regular square waveform like we had earlier in this video. But right here, like I said, I believe these are your messages, and they're supposed to be your dwell time messages and dwell time. But we got a bunch of crap going on in our dwell time. Now let me get that set back up. Oh, come on, computer. It almost acts like, you know, those are messages, but it almost acts like, so that's message, but these are something module trying to talk, or it's corruption. That's the issues. Issue, 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 not issue, not issue, not issue. And we got all the service stuff on it, and it's hot in here because the air's not blowing. I wanted to get it to go good again. We're gonna head back to the shop now.
Right now?
All right, so now, well, it went bad again. It was just good there for a sec. Just trying to turn the camera on. Now it's acting up again. We just had it good for a second. I don't know if I got that on camera or not, but if you, earlier in this video, it shows what a good signal looks like. I'm gonna pause until we get it good again. Bad again. It was good and it was bad again. Already it's good again, bad again. Damn it. Every time I turn my camera on. Hopefully I caught on film that last time. Looks like it's good again right there. They're getting good. Was good. So you can see breaks in the messages. It's getting cold. Yep, it's good there. Yeah, it's good. The air's cold. No messages on there. The air's cold. Hopefully you can feel that in the video. Look at those messages. Those look nice. Look at that. They look really good. Everything looks good. Now I stop and zoom in on this good messages. Look, all square waves. All go on the ground. None of that angle triangle bull crap you saw earlier. That's good messages there. And you can see there's gaps between them when they're not talking, and that's what you want to see. And everything is off. I mean, everything is working now. No messages on there. The air is cold. Now it's bad again. Look, it just went bad. Yep. Good, bad, bad again. Bad again. Good, bad. It's back and forth. You can see it there. Now it's throwing messages again. Air's, yeah, but it's matching. Now it's bad again. And our bad spot again. Good, bad, good, bad. On this bus message. Let me zoom in one more time. Good, bad. Square waves. And then you got all this bolt crap right here that's a redundancy. They look exactly the same pattern. Hopefully you guys can see that with this glare. But look, that's not a square wave. It's like just a sharp triangle point. And they look exactly. Is that hash from a connector issue? Or is that hash from a module? So like I said, what we're going to do next, we're going to take it back. We're going to go to those joint connectors. Now it's good again. I'm going to go to those joint connectors. We're going to take a look at the joint connectors. Well, it's going to unplug a module one at a time and we'll look at connections and see what we can come up with. See where we're at on the scope again. Bad right there again. So we'll do that next. All right, so I just wanted to talk before we go any farther. If this thing was shorted to volt or shorted to ground, it'd be 0 volts. If it was shorted to voltage, it'd be 12 volts. If it was shorted to 5-volt reference, it'd be 5 volts. But we had all that noise in there. Seems better now. It's getting cold again. It's not perfect. It's there. Now it's pretty good there. That looks like a good message. And it's cold again. No messages on the cluster. Look at that. That's a good message. We got, look at that. That is perfect. And it's working as advertised right now. We just got off the interstate. But again, when it does it, if it's shorted, we're not seeing that. We're seeing an issue whether, you know, loose connection, I usually see a sawtooth pattern on that bias voltage, but I ain't seeing that. And this doesn't have a bias voltage like CAN bus. So it's either a module issue. No, there's a software update for the steering lock module. Would that cause this? Maybe. We need to look into that as well and go from there. Oh, look, it's bad again. Service modules. This is like 5 seconds. It was good, and then 5 seconds later it went bad. Yep, it's bad again. All right, it's doing it again. We're almost back to the shop, but I'm not talking to it with the scan tool. We still get, I mean, obviously that's bad, but you get those high spots in there, even with not talking to it with the scan tool. Just wanted to point that out as well. We film a little bit more here before we drive it back into the shop, but it's bad there. Hope you guys can see that. And that went low there. It's doing that crap again. 5 volts. We're just sitting here in park. Went low again. Wonder why it's doing that. Going low again, or did. Just back up a few. Well, yeah, you can see that anyways in the film. Alrighty. Been in the shop again, running. It's bad right now. It goes good and bad. Well, it's bad because it's all gray again. So yet again, it's bad. I've been looking for software updates for the steering lock module for the TSB. It's already got the new software on it per GM Kel ID. I looked at all that. I've been looking at BCM stuff just to make sure. It's noisy again. Now it's good, bad. If you look, good messages, and there's your bad crap. So I think what we need to do is we need to get to it's not talking. We need to get to, probably going to be part 2 and we'll do part 3 later on. But we're going to have to get to, so this thing pulls up. Come on. Little low speed can. This joint connector, this one and this one. This one's behind the dash, which is up under here. I had that apart. I'm gonna have to find it under there. And what I want to do is, yeah, look, it's good again right now. Look, there's perfect. There's scaps in there, so that's good. The fault scan. It's good. There'll be colds in there because now it's bad again. What the hell. Anyways, I want to get to these joint connectors or these modules. Unplug one at a time. See if there's a loose connection on a joint connector or module causing issues. That'll probably be it for this part of it. This part 2, and we'll go to part 3 once I get a good plan together and go from there. Alright, it's doing it again here, and I want to show you real quick why it's doing it. Kind of work backwards here. This connector 10 is what we're looking at on the schematic. Come on. It's a stupid computer, so freaking slow here, right, Stevie? Low speed can. Still doing it. So this joint connector, this joint connector, this joint connector, they're a pain in the ass to get to because they're behind the dash and all that stuff. So, and to get to each of these modules, it's a pain in the butt too. You got for a plastics part. But if you look at X225 pin 10, if we take that off, then we disconnect these modules on this side or these other connectors here. So we're going to go X225. So it's doing it right now. Steve's going to film while I do this. It's this connector down here, a yellow one. Steve's going to film right here. Change a little bit. Go ahead and film, Steve. We got it. Now it's good again. Mother. Whatever. I want it to act up again. Now it's acting up. You can talk, Steve. Don't be shy. Is it acting up?
Yes.
Now I'm going to unplug the connector. Right hand on, I'll tell you when. Unplug it right there. I unplugged it. Now it's good, right? Now let me plug it back in. Plug it back in.
Bad.
And it acted up. Let me unplug it again. Unplug bad, right? Or good?
Good.
It's good. Let me plug it back in. Hang on. Plug back in. Bad? Alright, so we proved it there. What that's doing is we're taking X225 out, pin 10. We're taking more than that out, but that is the connector. So when we take that out, when it's plugged in, it's acting messed up, right? It's doing this stuff. When we isolate this and get rid of this from here, well, we are scoped right here, so we're looking at it backwards. We're scoped right here, so it's not on this side. Because we're plugged in, it's acting up, but we are scoped right here. That's where my pin is at on the scope. The green wire on here. I'm disconnecting this, so all I'm reading then is this side, not this side. Let me take a look at that some more. All right, we're getting some stuff narrowed down. I know I told you it'd be a separate video, but I want to know what's wrong. So it's acting up right now. You can see it. So when I disconnect X225, let's do that again. Steve, film. You can talk. Get your hand out of there. Sorry. No, not you, Steve. Okay, we're gonna. Is it acting up, Steve?
Yes.
Hang on. Is it better? It's getting better. Yep, now let me put it back in. Is it bad?
Yes.
Okay, go back to the screen over here. I can talk. So we disconnected X225. It went away when we did it. When we're scoped right there, if it went away when we're scoped there, that means this is good, correct? So now we're going to do X138. Follow me up here. Or no, show them where it's at. It's right here. This is X138. Go back to the scope. So it's bad right now, Stevie boy?
Yes.
Can you move? I can't see when your body's in the way. I'm going to pull off. I know.
Remember how to do it?
Yep. So I disconnected it. It's still bad, right, Stevie boy?
Yes.
Do you say anything but yes?
Maybe.
Okay. I'm going to put it back on. Go back to the schematics. So I disconnected it here. It didn't change nothing. So when I disconnect here, it takes this out and this bar out and these right here. And it didn't change, so it's not these. So it's telling me, if I'm looking at this right, it's this bar, which is under their, behind the radio, which these modules are your keyless entry pad, control module, parking assist control module, seat memory control module, accessory DC AC power module, inflatable restraint airbag module, and your passenger presence module. We can narrow these down, these modules maybe next with the other connectors, and then go from there. Alright, so my scan tool, I got to charge it, it died, but anyways, so these modules here and these codes, it shows it doesn't have this one, this one, this one, or this one. According to RPO code I scanned, but we'll verify. It has an airbag module, has the passenger seat module. I unplugged the passenger seat module. They got the same results, which didn't change it. What's showing me left is the airbag module, but I'm not saying that's causing the problem, and it could be, but that's what's left in the circuit if we're looking at this right. So we're gonna go after that and do some more, you know, oscilloscope work. So that'll be it for this part 2 for this video, and then we got to keep going and see what happens in part 3. Bye. Well, this was the part 2 video, like I said. So yeah, it's been a fun one for sure. So what I'm thinking about doing now is, well, first off, the RPO code doesn't show that it has some of those modules like I showed in the previous diagram in this video, but if you scan it, it does have them in this vehicle. So I need to look at that some more. Look at that, the airbag module. Look at, maybe there's a wire chafing in something or a corruption in the module. We need to get to these, either these joint connectors or the modules, and start, you know, going from there. So there'll be another part of this video. I just got to get my scan tool charged up, get some more schematics, download it, print it off, and go from there.